Now we're going to look at conditional probability, which means it depends. Back in chapter 3, we looked at contingency tables where you saw, oh, this person was conservative, and if they were male or female or liberal or whatever. So we're going to take those same ideas and apply them here for what's called a conditional distribution. And the main thing is we write this probability of B given A. This vertical bar here is pronounced as given. So probability of B given that A happened. You know that A occurred. When you know that one of the conditions occurred, that is conditional probability. So I don't want the probability of B in general. I want the probability of B knowing that A happened. All right. So if I know that A happened, A becomes my total. You might be, well, wait a second, A is not 100%. Well, in this case, I've kind of restricted my range, and I'll show you what I mean in the next two examples. So we're just going to take the fraction of B that can happen in A over the probability. So that probability of B and A happening at the same time, and divide it by the probability of A. All right. Know that the probability of A cannot equal 0 because we know that A has occurred. So we're never dividing by 0. All right. So here's an example. Miss Wu teaches Geometry and Algebra II, and the probability that a student will get Miss Wu for Geometry is 0.18. The probability a student will have Miss Wu for Geometry and Algebra II is 0.03. What is the probability to the hundredths that a student will have Miss Wu for Algebra II if they had her for Geometry? So let me write down my probabilities. I know the probability of someone having Miss Wu for Geometry is 0.18. The probability of someone having her for Geometry and Algebra II is 0.03. This is the formula. It's on your math chart. And so what you want to do is look at the probability that both happen, divided by the probability of the one that you know happened, which is this one, 0.03, divided by 0.18, about 0.167. Let's go ahead and look at this again from the terms of a picture, because it can be easy to get lost in these formulas. So here's Geometry. Here's Algebra II. You're probably going, well, I don't know a lot for this. I can't fill out the whole Venn diagram. And you're right. So I'm going to fill in the 0.03 for the Algebra II and Geometry. Remember, it's always easiest to fill out that overlap section. Now, instead of 0.18 over here, I know 0.03 is over here, so that leaves 0.15. Well, in this example, our world is confined to this. We don't care about the rest. We know the student got her for Geometry. So we're just looking for the part that's in both right here out of this whole. And you're probably saying, well, this whole is 0.18. That's okay. We know it happened. So that's my new whole. Okay? Let's take a look at another example. And I'll do it with the equations and I'll do it with the picture. I draw one card and look at it. I tell you it is red. What is the probability it is a heart? Now, you're probably going to intuitively tell me it's 50%, and you're right. And then, what is the probability it is red given it is a heart? And you're going to tell me intuitively 100%, and you'll be right. So let's look at the math behind it. Probability of a red card in general is 0.5 or 50%. Probability that a card is red and a heart at the same time is 0.25 because there are 25 red hearts. Probability of a heart is 0.25 because there are 25% of the cards are hearts. So if I do this all mathy-like and say probability of a heart given that it's red, that means it's the probability of a heart and red over probability of a red. Now you will have a math chart, so you don't have to memorize this, but the way I remember it is it's both of these on top and that one on bottom, kind of like it looks there. So in case you like to memorize. So anyways, let me go ahead and fill in the values without thinking. Here we go, heart and red, that's the same as red and heart, 0.25. Probability of red is 0.5. Guess what? It works out. Intuitively, we knew that the probability of getting a heart, if we knew the card was red, was 50%. And if I fill in for red and heart, that means red and heart, that's 0.25. Probability of a heart, that's 0.25. That's 100%. And intuitively, you knew that. If you got a heart, you know it has to be red. So finally, let's look at the picture. So we have our hearts and we have our red cards. Well, let's see. There are 13 hearts, and they're all red. And then there are 13 other red cards. There are no cards that are hearts and not red. So you can see, if I ask you what's the probability it's a heart given it's a red, that's 13 out of 26. If I ask you what's the probability a card is a red given that it's a heart, there are 13 reds out of 13 total. Let's go ahead and take this to tables like the conditional tables we looked at last time. So here we have a table of students wearing jeans in a class. Big class, by the way. What is the probability that a male wears jeans? So looking at the top row here, I can see what I'm going to do is I'm going to restrict my world to this row. I do not care about anything else because I'm talking about males. It is given that the student is a male. So the way I write it is probability of wearing jeans given the student is male. So that means you can actually, here you're like, wait, do I have to go calculate all the probabilities? If they're both in the same form, you can just do the counts instead of the probabilities. So that's a lot of times how I calculate it. So how many are male and wearing jeans? There are 12. How many males are there? There's 17. And that's your answer. Okay, let's look at it a different way. What is the probability that someone wearing jeans is a male? So we're going to change our world. We're in this column. This is the only one we care about. So we know they're wearing jeans, and we want to know if they're male. So you go, what is the probability that they're male given that they're wearing jeans? So it's jean and male over jean. So jean and male is 12 over, and then jeans is 20. So you can see that the probabilities are different depending which condition is given. By the way, are being male and wearing jeans disjoint? Disjoint is the same as mutually exclusive, same thing. No, they are not mutually exclusive. There are some who are both male and wearing jeans. So again, just to remind you what mutually exclusive means.